Oppo Reno8 Pro 5G camera test. Peace be upon you, my dear friends and followers of the channel. How are you today? I hope you are well and in good health. Today with you is a beautiful, new and important video for everyone. This video will be called the Oppo Reno8 Pro 5G camera test. But before watching the video, subscribe to the channel and like and share so that it reaches the largest number of people. Now let's watch the video and I hope you like it. We subjected the Oppo Reno8 Pro 5G to rigorous XMark camera tests to measure its performance in photo and video quality and zoom from an end-user perspective. In this video I will explain the device's performance in a variety of tests and several common use cases and aim to highlight the most important results of our testing through a snippet of captured data. Overview. Main camera specifications. Primary, 50MP sensor, 86° field of view, f/1.8 aperture, autofocus, ultra-wide, 8MP sensor, 112° field of view, f/2.2 aperture macro, 2MP sensor, 89° field of view, f/2.4 aperture pros. Accurate exposure, wide dynamic range. Overall fairly good detail in photos and video. Consistent autofocus and wide depth of field in photos. Well controlled noise and video cons. Often inaccurate colors in photos and videos. Tone compression in HDR portrait images. Noise in images. Occasional shadows and halo in images. Occasional choppy autofocus and video. Instability of white balance in video. Animated texture effects in low light videos. Loss of fine detail at medium and long range telephoto zooms with an XMark camera score of 114. The Oppo Reno8 Pro 5G occupies a middle position in the premium segment ranking. The camera's overall performance was acceptable for the price point, with good results for photos, video, and even telephoto zoom. Despite the lack of a dedicated telephoto lens, overall, image quality and performance seem to be fairly good in bright light and under typical indoor conditions. However, there was a noticeable drop in quality once the camera was used in low light. This was especially true for video mode. When shooting still images, the camera provided accurate exposure and a wide dynamic range in most conditions, capturing good light and shadow detail. However, portraits taken in high contrast lighting conditions were susceptible to tone compression artifacts. Autofocus was a little slow in some situations but was stable. A wide depth of field means that elements behind or in front of the main subject are still fairly sharp. Images provided good detail, but this came at the cost of some noticeable image noise. Color could be better too, as still images often show unpleasant colors. Our testers also noticed ghosting and halo effects in scenes with moving objects or when shooting in high contrast conditions. When using the telephoto zoom, fine detail was lost at medium and long range settings, but overall the telephoto zoom did a fairly good job, considering the lack of a dedicated telephoto lens. The image quality of the ultra-wide camera was fairly good as well. Videos using the Oppo came with good exposure and dynamic range, but exposure instability was somewhat noticeable. The same applies to white balance instability and reflections. As with the photos, the colors sometimes look a bit off. Breathing can be very annoying as well. On the plus side, video stabilization worked very well, doing a good job of compensating for camera movement. About XMark camera tests. XMark camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. Results are based on objective tests, the results of which are calculated directly by measurement software in our laboratory settings, and on perceptual tests, where a sophisticated set of metrics allows a team of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the XMark camera protocol for recording and analysis, XMark engineers capture and evaluate more than 2,600 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings. The photo protocol is designed to keep key use cases in mind and is based on typical photography scenarios, such as portraits, family portraits and landscapes. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by performing objective measurements on histogram images taken in the laboratory under various lighting conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure and color are the two main characteristics of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors that are evaluated are contrast and dynamic range. For example, the ability to provide visual detail in both bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. Autofocus tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually captured. This includes focusing speed and the device's ability to capture images at the right time, which is called no shutter lag capability. Even if a shallow depth of field is pleasing for a portrait of a single subject or a close-up shot, it can also be problematic in some specific circumstances such as group photos. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured, from infinity to close-up subjects and in low light to outdoor conditions. Texture tests analyze the level of detail and texture of subjects in images captured in the lab as well as in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on chart images captured under different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The charts used are the Special Exomark, DMC, chart and the Dead Leaves chart. Noise tests analyze different noise attributes such as density, color, granularity, and structure in real-world images as well as chart images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also on dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are made on chart images taken at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The chart used is the Dead Leaves chart and the standardized measurement is visual noise derived from ISO 15739. The effects assessment looks at lens vignetting, chromatic aberrations, geometric distortions, edge ringing, halos, ghosting, quantum, and unexpected hue shifts, among other types of possible unnatural effects on images. The more severe and more frequent the effects are, the greater the points deduction on the score. The main effects observed and corresponding loss of points are listed below. Preview tests analyze image quality in the camera app's preview of an image, paying particular attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color and focus adjustment are also evaluated when zoomed from the minimum to maximum available zoom factor. Preview frame rate is measured using the global LED timer. Exomark engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings and dial zooming at various zoom factors from ultra-wide to ultra-long range zooms. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by making objective measurements of histogram images taken in the laboratory under varying conditions from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. These tests analyze the ultra-wide camera's performance at several focal lengths from 12 mm to 20 mm. All image quality attributes are evaluated, with special attention paid to such artifacts as chromatic aberrations, lens smoothness, and distortions. The images below are excerpts of the scenes tested. Exomark engineers capture and evaluate more than 2.5 hours of video in controlled laboratory environments and in low-light landscape scenes, both indoors and outdoors, Using default camera settings. The evaluation consists of visually examining naturalistic videos captured in different conditions and performing objective measurements on videos of histograms recorded in the laboratory under various conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure tests evaluate the brightness of the main subject and dynamic range. That is the ability to display visible detail in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. Color image quality analysis addresses color rendition, skin tone rendition, white balance, color shading, white balance stability and its adaptation to changing light. Texture tests analyze the level of detail and texture of real-life videos as well as videos of textures recorded in the lab. Natural video recordings are evaluated visually, with special attention paid to the level of detail in bright areas as well as in the dark. Objective measurements are made of chart images taken at various conditions from 1 to 1000 lux. The charts used are Xmark, DMC, chart and dead leaves chart. Noise tests analyze different noise attributes such as intensity, color, granularity, structure, and temporal aspects in real-life video recordings as well as videos of histograms captured in the laboratory. Natural videos are evaluated visually, with special attention paid to noise in dark areas and high dynamic range conditions. Objective measurements are made on video clips of histograms recorded at various conditions from 1 to 1000 lux. The chart used is the Xmark Visual Noise Chart. The stabilization rating tests the device's ability to stabilize shots thanks to software or hardware technologies such as OIS, eyes, or other means. The evaluation looks at residual motion, smoothness, gel artifacts, and residual motion blur in walking and running use cases in different lighting conditions. The video below is an excerpt of one of the scenes tested. Artifacts are evaluated using MTF and ring measurements on an SFR chart in the lab as well as frame rate measurements using the global LED timer. Natural videos are evaluated visually by paying particular attention to unwanted artifacts such as aliasing, quantization, occlusion, and color shift, among others. The more severe and frequent the unwanted events, the more points are deducted from the score. Below is a list of the main undesirables and their corresponding points loss. At the end of the video, I thank you for watching and I hope you liked it, and see you in a new video.